All right, so we are revisiting this first part that we already looked at. Let's reread the question so we know what to do here. Students who completed a class participated in a year-long study to see how much content from the class they retained. So at the end, they took a test. When time t equals 0, they had a 75. That's where we got this ordered pair, okay? When t equals 3, it was 70.84. That's where we got this ordered pair, right? Natalie, come get the notes. If you weren't here yesterday, come get what you need to. You have them? Then what are you doing?
I'm sorry. He's really scared of me because I'm sick.
Oh, well, whatever. Just get your notes out. Okay. And so then we took those two ordered pairs. They gave us what our natural log equation is supposed to look like. We put in the information to write two equations, but we literally do nothing else, right? Take your earbuds out, Mel. And then we're supposed to find A and B. So we're going to go to Desmos and type in our information. So you're going to need to retype it in because you don't have it from yesterday because we're going to do some extra stuff. 0, 3, 75, and 70.84. Okay. So those are the two ordered pairs we got. That's what we're typing in, right? I can zoom and then regression, and I want a logarithmic regression, and we have a problem, right? If you do anything in Desmos and you get this, although this is the first time I think I've gotten that, but I'm sure there's other things you could do where that happened. If you click on it, it will tell you what the problem is. Sometimes when you get alerts, at least for me, depending on what we're in, you click on the alert and it still doesn't make any sense. You don't even understand what they're saying, but I think we can make sense of this. So this says logarithmic regressions only work if the first column is all positive numbers. So remember, when we do it like this, using this nice little menu that they give us, the only thing it's going to give me for a logarithmic regression is a plus b times the natural log of x. And so it's trying to take the natural log of 0, which we know is undefined. That's why it's not working. It does not mean that I don't have an answer here, because on this equation, it's actually t plus 1. So when I put in 0, I get 0 plus 1, and then it'll work. So what we need to do, and remember, I told you yesterday, I was trying to decide if we're going to do 100% calculator or a mix of the two. But last year we did a mix of the two, and there were times where you didn't need to do things by hand, and people did, and it was a hot mess of wrongness. So I think if we just kind of do all our regression stuff and know what to do with the calculator, we're better. So for logs, we either manipulate the regression like we did on some yesterday, or we manipulate the x values. And since it's not working with the x values I have, and I have this t plus 1, then I'm going to add 1 to my x values, so I actually get a 1 and a 4. So I'm going to change this one to 1 and this one to 4. Okay? Does everybody understand why I changed them? Yes? Okay. So even though this says 75 minus 3.00081 times the natural log of x, because I added 1 here, my input is actually x plus 1, which is what I wanted, right? So we either manipulate the regression, which we did on the others, because that's when we were changing what kind of log it was, or we manipulate the x values. We do not do both, which means I'm going to do something, and then I'm going to undo it, so don't copy me. On the other ones, we were doing this and export as a custom regression. When I do that, if I adjust things in here, A and B change because I'm adjusting the regression itself that calculates everything. We do not want to do that. It actually gave us the numbers that I need because technically this is x plus 1. So over here, which I think we might have already done yesterday, is we write down A is equal to 75 and B is equal to negative 3.00081. Okay. Now let's go back and look at our graph. So on some of the other ones, we wanted to figure out what was happening when x equals 4 or whatever. So if I go and I put my vertical line in to see where things intersect, the problem is this graph is actually this equation that I actually see here and not the x plus 1. And I know that my ordered pairs, I'm supposed to have 0, 75, right? Well, when x is 0, I can tell, I don't know where it is, I can zoom, but it's not at 75. So this graph is not correct. I adjusted my x values. I am not going to adjust my regression, but I need my equation to be what it's actually on my piece of paper. So right above this, it literally says equation. When you click that, do you see how I didn't get the little subscripts and stuff, and I don't have A and B down here? So it's not changing the regression. It's not going to recalculate anything for me. It just put the equation in there. So then I can fix this and make it x plus 1, just like it is on my paper. And by doing it that way, I'm not retyping in decimals. Even though I see decimals up to the 1, it's storing more, all that good kind of stuff. So now I can see my original points of 0, 75 and 3, 7.84. Well, basically right there. I can't get it to stay, but the blue one you see, that is my actual curve. Okay, does that make sense to you? So remember, we either adjust the regression or we adjust the x values. Okay, everybody okay with that? You see how they're different? And we're going to practice with this some more so we can make sure we know what we're doing. But all right, so let's go back to this. It says use the given data to find the average rate of change of the scores and points from 0 to 3. So if I'm finding average rate of change, what am I looking for? What's average rate of change? Slope. It's just the slope. It's just slope. And although you don't have to, I always rewrite this in interval notation just because it makes me feel better. All right, now on the calculator, on Desmos, we have x and y. The question is actually using r and t. So we got to make sure we're doing this correctly. So slope, hopefully we're experts at this by now. We're going to have r of 3 minus r of 0 over 3 minus 0. Okay. That is my function notation part of it. Then I substitute in what I know. What is r of 3? 70.84, good. And r of 0 is 75, and that is over 3. Okay. Then I can go back to the calculator so I can do some calculations. I don't need my graph or anything. So right here, I'm just going to do divide. So I can do 70.84 minus 75 over 3. Okay. So I have negative 1.38666. So negative 1.38666. Any questions at this point? Okay, so now we are going to change the second part of the question because it's the other part that I thought I changed and I didn't. So I'm just going to mark that out. We're going to write a new question. So this is going to say, using the average rate of change from I, so basically what's right above it, okay, predict the score for t equals 4 months. Okay, so using the average rate of change from what we just did, predict the score for t equals 4 months. All right, so this very well could show up as an actual question on your FRQ, and it did last year, and we're going to practice on this some more. There's 2 ways to go about this. Showing you how to just manipulate the slope, which is how we've done like one of these so far, but we're going to do a whole lot more. Or having you write the equation of a line. And I showed both ways last year. I think I've just this year said we're just going to do it the slope way, because I'm afraid, I feel like by now, if you can't write this and figure out slope, we got other big problems. And that makes sense to you now, hopefully 100%, so that if we just take that and manipulate it, that's better than trying to write an equation when we really haven't written very many this year. Okay, so we're going to stick with slope. But I want you, we're going to draw little pictures over here because I want you to understand what is happening and what we're doing and why it's even asking us this. So we have this curve, which, and if you're not sure what it looks like, you can go over here and go, okay, I know it was logarithmic and it looks like that. We can see it. So this curve looks something like this, right? And we have these points at 0 and then at 3, like wherever it is, you know, just, there's no scale here. It's just so we can kind of understand it. And we found the slope between those 2 points. So it's basically the slope of that line, of my pink line. Okay. If I want to know the rate of change at 3, like at a point, that requires calculus. But we can find average rate of change because it's just slope like we've been doing forever. So that's what this gives me. This average rate of change that we found is just what it says, the average rate of change between 0 and 3. But I want to use this to predict it at, so let's see, this is 0, this is 3. We want to use it to predict at 4, okay? Which means I'm going to be able to find a point on my pink line, which is a prediction for on the blue curve, okay? What I really want is what's on the blue curve, but I don't have the skills to find that yet. But I can predict that value by finding another point on that pink line. Does that make sense to you? If I find this point at 4 on that pink line, would it be an overestimate or an underestimate for what is happening on the curve? Underestimate, okay? Because I can see that it's literally under it. If I used this slope to estimate at 2, which would be like right here, then it would be an overestimate, right? This line is intersecting the curve at 2 points because it is a secant line. From 0 to 3, the line is above the curve, and from 3 to infinity and from negative infinity to 0, it's below the curve. So that's where your overestimate and underestimate are coming from. It doesn't ask me here if it's an overestimate or underestimate, but it totally could. So just want to make sure we understand what we're doing. So if I'm going to find a point on this line, the slope is the same for the entire line always, right? And we're going to take the slope that we would already have written, and we're going to adjust some things here. Meaning that I'm going to replace, so I have this, I want to predict it 4 months. So my input is 4, my output is R of 4. So basically I am looking for R of 4, right? It doesn't really matter which one you replace in the slope, but if you want to get a positive at the end and not have to worry about negatives, it's best to replace this first one. So I've got, basically 2 points here. I'm going to replace this first one with what I'm looking for. So that means this is going to be R of 4, and I'm going to leave the rest, minus R of 0 over 4 minus 0. Okay, just like you would write down any slope. Then I'm going to substitute in what I know. I do not know R of 4. I'm looking for that. What is R of 0? 75. And then that is over 4. Okay. Now, this slope, because this point for R of 4, I'm actually getting as a prediction from the line. So this slope has to equal this number. This equals negative 1.38666. Okay. Any questions about what we're doing and where stuff came from? Okay, so now solving for R of 4 is pretty simple, right? I would take this number and then do what? Multiply by 4 and then add 75, right? Just a simple, like you don't have to write it all down. So you've got 2 options over here. I only have one because I can't make it happen on the board. But when you do this, I can type in my 5 decimal places, and we're going to look at why we're using 5 in a second. Or I got this to work in one class and not, oh, now it's working. But you can highlight it and then you can Control C to copy and then Control V. You could actually just copy and paste that number down here if you wanted to. But I can't do that on my board like I am. So I'm just going to type in negative 1.38666. 666, my 5 decimal places. I'm going to multiply that by 4, and then I add 75. If you copy and paste that number, you will get 69.4533333, where that means the 5th decimal place would be different, but we only have to be actually correct to what? 3, so we're good, all right? But I want you to see what would happen if, this is why we can't round in the middle. If I didn't use 5, if I used 3, now I'm not correct to 3 decimal places. You see that? So that's why you have to, that's why we're writing down more so that we have them if we need them. But you can also, even if you can't store it at this moment, you can highlight it and then copy paste and, you know, do your keyboard shortcuts that hopefully you know how to do. But let me put this back in here correctly. This is supposed to be 333, right? Oh, no. It's not a 666. There we go. Okay. So what I got was R of 4 equals 69.45336. And if you have 333, it's fine to write 333 because you copied and pasted. Both answers would be considered correct. What are my units here? It's 69 what? Question. Points, right? Points. Is that a reasonable answer, do you think? Do we expect it to be less than the 70.84? Because we expect it to go down, right? Because of what the graph is doing. And remember, this is an estimate, but it is an underestimate for the actual number. We don't know what the actual number is. That's okay. What questions do you have? All right. So now then this next part says, consider the average rates of change of R from t equals 3 to t equals p months, where p is greater than 3. And I know just reading that one sentence, most of you are probably like, what? Just read the whole thing and then go back and we'll make sense of it. Are these average rates of change less than or greater than the average rates of change from 0 to 3 months? Okay, so again, I think drawing little pictures, I mean, I do this for myself too, to wrap my mind around this. My graph looks something like this. And I had points at, we'll make that 0 and 3, whatever. It doesn't matter really where they are. So this is at 0, this is at 3. So it says, consider the average rates of change from 3 to p, where p is greater than 3. So from 3 to p, that's 3 to p is over here somewhere, right? So it's saying basically past that point. And I want to know, are they greater than or less than the ones from 0 to 3? Well, we found one of them from 0 to 3, right? But if I went from 0 to 2 or 1 to 2, like all these rates of change, any rate of change I find from here to here, how does it compare to the average rates of change I find later? That's what it's asking. Now, you could do some computation and say, hey, well, I found some others, so clearly it's smaller. That's not what they're asking you for. You don't have to do any more math with this. We just have to have an understanding of what's happening. Is this function concave up or down? Up. And if it is concave up, what does that tell you about the rates of change? And if you don't know off the top of your head, what do we write down? The fun chart. Okay. Write down the fun chart. I know some of you kind of have the fun chart in your head, but we'll write it down. Okay, so concave up means the rates of change are increasing. Since the rates of change are increasing, the rates of change from 3 to wherever p is, would they be greater than or less than the rates of change right here? Greater than, because it's increasing, right? So we're using it based on what we know about functions. It's a functional analysis thing. So this is what I would say. Now we're going to write a lot, but it's not like I'm not going to remember how to write this paragraph. A lot of what we're doing is restating what's in the question. So I'm going to start with average rates of change of R from t equals 3 to t equals p months Now that, I literally just rewrote that part right there, okay? Just restating it. I'm quite sure y'all are good at restating the question so you can answer it. Okay, so average rates of change of R from 3 to P months are, and we said they are what, greater than or less than? Greater than from T equals 0 to T equals 3 months. Okay. And again, just pretty much got that from the question. Now that's my answer. I don't have my explanation there. So I'm going to say because, and I'm not using it, right? It is not in our vocabulary, because R is concave up. And that's only half of it. That's true, it's concave up, but you have to state that you understand what concave up means. Because R is concave up, therefore, average rates of change are increasing. Okay. What questions do you have? If you're going to state something from the fun chart, make sure you don't only do half of it, like just saying it's concave up. The reason we looked at that is so that we would know about the rates of change. So make sure you talk about both pieces. Any questions? And I know just because of the things you've learned in English class throughout the years, you're good at restating the question to answer. But I'll also say when I was grading the test on one of the last ones, a lot of you worded it differently than it was probably in your notes, which is fine, because you said the same thing. But it looked to me like, which is a good thing, that you knew it was whatever function it was. And so then you went back to a question where in the multiple choice part, it stated the reason why, and you copied that down. And that's a perfect test taking strategy. Okay, absolutely perfect. Because at first I was like, wow, there's a lot of people saying that. And then I caught on to it and I was like, no, this is good. That is what you should do. And then you can be confident in what you're doing. Okay.